Imagine you're a data scientist looking at a bunch of data points, but you have no idea what categories they belong to. There are no labels, no hints, just dots on a screen. How could a computer possibly find patterns in that chaos? That's where k-means clustering comes in. It's one of the most popular unsupervised learning algorithms, and it helps us automatically group similar data points together. When we say unsupervised, we mean there's no teacher. Unlike supervised learning, there's no right or wrong label. The algorithm just looks for structure, for groups where data points are closer to each other than to other groups. Let's break it down step by step. We start by choosing a number, k, which represents how many clusters we want. For example, if we believe our data naturally forms 5 groups, k equals 5. Then, the algorithm randomly picks k points as centroids. Think of them as temporary leaders of each cluster. Next, every data point checks. Which centroid am I closest to? It measures the distance, usually Euclidean distance, and joins the cluster of the nearest centroid. So now every point belongs to one of the clusters. After all points are assigned, the algorithm updates each centroid. The new centroid is placed at the mean position of all the points in its cluster. Hence the name, k-means. Once we've moved the centroids, we repeat the process again. Points get reassigned to the nearest centroid. Centroids get updated again, until nothing changes anymore. Let's make this more intuitive. Imagine you have a big pot filled with balls, some red, some blue, green, yellow, and purple. You don't know which color is which, but you want to separate them into 5 groups. The k-means algorithm starts by picking 5 random balls as centroids. It measures how similar each ball is, maybe by color intensity or some numeric feature, and groups them around the closest centroid. After a few rounds of updates, the algorithm naturally sorts the balls into their correct color clusters. The algorithm stops when the centroids stop moving. That's called convergence. At this point, the clusters are stable, and that's the magic of k-means. It doesn't need labels, supervision, or prior knowledge, just a way to measure distance. But how exactly do we measure that distance? In the next video, I'll show you the most common methods, and why picking the right one matters more than you think.